Hi, let's try to do this problem now. Let's rewrite it in a compact way. So let me first make this a little bit smaller, just like this. And now what I'm gonna do is I'm gonna write here x double prime plus y double prime equals to t squared. And here I'm gonna have x double prime minus y double prime is equal to 4t. So I see a very particular situation here because I could just add them up, and if I add them up, I'm gonna get 2x double prime equals to t squared plus 4t. So I have an equation just in terms of x double prime, which is good because then I can just solve this without having to do a system. And I divide by 2 on both sides. I get this. Or if I want to split it, because with the Laplace I always want to split it, this becomes plus 2 times t. And now, can we do something with the y as well? Well, if I multiply the bottom by negative 1, I'm going to get minus x double prime plus y double prime equals to negative 4t. Now if I take this and I add it, I'm gonna get that, so this canceled out here. Now this cancels out here, and I'm gonna get 2y double prime is equal to t squared minus 4t, or y double prime is equal to t squared 1 over 2 minus 2t. Now, reality check. I did the same thing on the left and on the right, because if these are equations, when I added this bottom equation to this top one, I added whatever was on the right, I added the same thing on the right on the left, because this equal sign is telling me that they're equal. So I didn't change the value of this thing, of this equation above. So this should be an equivalent way to express x double prime of t, but without y double prime. And same as this one right here. So now if I apply the Laplace, transform to these functions, I get that the big X times s squared minus s times x of 0 minus x prime of 0. That follows the development of a second order derivative to which you apply the Laplace. And on the right, we're just going to get 1/2. Now, if I look back at my table, the t squared, if I have a t squared, it's going to be, in Laplace domain, it's going to be, on the numerator, the factorial of the exponent. So it's going to be 2 factorial, which is just 2 times 1, which is 2, divided by s and that exponent plus 1. So that's going to be s2 plus 1, which is 3. So we're just going to get 2 over s to the third here, plus 2 times the Laplace of t is 1 over s squared. So this is going to be 2 over s squared. Now, I can do the same for the y. So we get s squared y, big Y, minus s times y of 0 minus y prime. And I'm being inconsistent with my notation here. I'll stick with this notation of 0 equals 2. Here we're still going to have 1/2 times 2 over s to the third. Now notice how these cancel out. Plus 2, or we have a minus here, minus 2 over s squared. So now we have these. We can input the initial conditions that they gave us. So they gave us 8 for x of 0 and 0 for x prime of 0. So 8 for x of 0, this is 8, and this is 0. We like the zeros because they get rid of a whole term. And then here we have 0 and 0. So now let's try and rewrite this thing. So let's rewrite it, and we'll have s squared minus 8s. Well, I forgot the big X. So s squared times big S minus 8s minus 0 equals to 1 over s to the third plus 2 over s squared. Let's do this other one, s squared y minus 0 equals to 1 over s to the third minus 2 over s squared. So I can solve for y pretty easily. Let me bring these closer in. I can solve for y pretty easily. I can just say, where am I gonna write it? I can just say that, and I can solve for x too. So let's solve for both. So from this, we're gonna have two equations. And I'm gonna indicate their separation like this, and we're gonna have, I'm gonna add 8s to both sides of the top one, so I'm gonna get x times s squared equals to 1 over s to the third plus 2 over s squared plus 8 times s. Now if I divide by s squared here, I'm going to get s to the fifth here. I'm going to get s to the fourth here, because what I'm doing is, if I divide by 1 over s squared, it's really like multiplying by 1 over s. If I divide by s squared, is like multiplying by 1 over s squared, and this one was s to the third. The exponents add, then you have to distribute that for each term. And here, if I divide it by s squared, this is going to go away, and here we're just going to have an s, assuming that s is not equal to 0. So now that we have this, I can go on the other expression, on the other equation, and I can divide by s squared. And I get 1 over s to the fifth minus 2 over s to the fourth. And now I can apply the Laplace inverse. So if I apply the Laplace inverse, what do I get? So I apply the Laplace inverse here. Well, here I get x of t, and the Laplace inverse of 1 over s to the fifth, I don't know, let's write it like this, and let's see how we can manipulate it. This one will have 2 over s to the fourth, and this one we know what it is. It is 8 times 1. So it's just going to be equal to 8. For this guy, we have y. It's not in the s domain, it's in the t domain, is equal to Laplace inverse of 1 over s to the 5th minus 2, well, the Laplace inverse of 2 over s to the 4th. So let's see how we can do this. So I am looking at the table, and I'm noticing that there's a part of the table. So I'll write it over here, Laplace table. There's a part of the table that has f of t and big F of s. And f of t is t to the n. And here I have n factorial divided by s to the n plus 1. So here we have something that could resemble this if we say our n is 4, because at the bottom we have one more than what our n should be. So we need the top to be 4 factorial. In order for the top to be 4 factorial, what I need to do is I need to multiply by 1, but a 1 that makes it into that form. So if I put a 4 factorial, multiply by 4 factorial, I need to divide by a 4 factorial here. And we can say the same thing here. So let's take that 2 out, and now here we'd want a 3 factorial, but then we want to divide by a 3 factorial. And I put it in the wrong, because this is all one thing. So we want to divide by 3 factorial. And now we can do a similar thing here. We actually have the same thing. So if this becomes a 4 factorial, we divide by a 4 factorial. And if this is a 3 factorial, and here we had a 2, and this was negative, here we divide by a 3 factorial. So now what do we get? X of t is equal to 1 over 4 factorial, which is 4 times 3 times 2. 4 times 3 is 12, times 2 is 24. So 1 over 24 times, now we can say that this is t to the 4, to the 4th. And then here we have plus 2 divided by 3 times 2 times 1. So the 2's go away, and we just have 1 over 3. And here we can say t to the 3rd plus 8. And for y of t, what we can say is we can say 1 over 24 again times t to the 4th. And then we have minus 1 over 3 times t to the 3rd. And these should be our answers. I'll show you in part B how to do it in MATLAB and how to check whether these are indeed correct. I'll see you there.